Good morning, learners. I am Dr. D. Paradesi, Associate Professor of Chemistry, SRM Institute of Science and Technology, Kattakulattur. In my previous video lecture, I have explained about the basic principle behind corrosion and what are the methods, how the corrosion occurs, what is the chemical reaction behind that. Everything I have explained in my previous lecture. So this is the follow-up of the previous lecture. How now in this lecture we have to learn about the corrosion control. How can we avoid corrosion? Okay, so what is the learning outcome? As I said already, how can we control the corrosion? What are the parameters involved? What are the conditions to maintain? Okay, and what are the methods to be followed to avoid the corrosion occurs? Okay, so look at the picture. So there are a lot of bolts and nuts. So it is fully reddish brown color layer found on the surface. Okay, so look at this is the show this. Yeah, so these are all the region. Look at it's very intensively the corrosion occurs. So what is the reason behind that? As I said in the previous lecture, it is based on the medium environmental conditions. Okay, so mostly corrosion, this kind of corrosion occurs by the acidic environments. Okay, now, so what are the major factors influencing corrosion? There are two major categories. One is based on the nature of the metal, and another one is nature of environmental conditions. So these are all the broad classification of corrosion. Okay, so what kind of material, metal we are using, and what is the environment your object is present. So nature of the metal means what kind of purity of the metal, what is the physical state of the metal, what is the layer formed on the metal surface, either it may be oxide film or chloride, sulfates, whatever it is, based on the environment, based on the chemical environment, the layer will be formed. So what kind of nature of the film, whether it is protective, whether it is porous or non-porous. If it is porous, then corrosion occurs continuously. If it is non-porous, the metal will be protected. So this is the basic thing. And what is the position in environmental, electrochemical series? If very closer in the electrochemical series, the metal will be protected. Okay, relative area of cathode and anode, and the solubility of products of corrosion, and volatility of products of corrosion. So these are all the conditions based on the metal. Okay, another aspects, environment. What kind of environment your metal is there? Okay, so the first basic one is temperature and humidity. If the temperature is increases, obviously the rate of corrosion will be increased. And effect of pH, acidic medium, the corrosion will be taken very quickly. Nature of electrolytes. Okay, what kind of electrolytes? And conductance of corroding medium. Formation of oxygen concentration cells. So difference in the oxygen concentration between the anode and cathode. And suspended particles. Okay, impurities present in the atmosphere. So these are all the environmental conditions which influences the rate of corrosion. Okay, so the corrosion, how can we now let us see what are all the method to control the corrosion. So the first one is you have to choose the right material for your applications. So the material should have high purity. So depends upon your applications. And then design modifications. You have to design the materials to the maximum. You have to avoid bolts and nuts. Joints should be reduced. Okay, that is material selection. And then coating and lining. So you have to properly coat your metal. So simply we can say if you are having some iron rod wherever you are using, it is always advisable to coat, that is a painted. You have to frequently see, even in our day-to-day life we are seeing in our gate, grill gate, lot of grill gates, definitely it should be painted, at least depends upon your environmental conditions. Okay, so once in a year you have to paint, either in the gate, wherever, not only gate, whatever the material, whatever the iron based product in your home, so it should be coated properly. And then environmental conditions, so we have to maintain according to that, what kind of environment we have. So these are all the simple way to control the corrosion. Simply we can say prevention. Okay, now let us see in depth. So whatever I have explained in the previous one, so little bit in depth we have to study. So material selection, the first one. So as I said already, the based on the application, you have to choose the material. Say for example, surgical hospital equipments, surgical related equipment. Mostly you can see that stainless steel material or some specific surgical material. It should be the noble metals. So complicated, some sensitive kind of equipments. So the best way of choosing the metal is noble metal. Okay, so and ornaments obviously we know that gold, silver, platinum, these are all the metal used as an ornament. Okay, in the second category, pure metal. Suppose if some impurity is in your metal, there is a possibility of corrosion. Okay, so and another thing, this kind of impurity creates a heterogeneity. So if you are having metal, so along with the metals, some other metals are available, so that forms a heterogeneity. Okay, so that increases the rate of corrosion. Even 0.02% of iron in aluminium. Suppose you are having aluminium, in that aluminium 0.02% of iron is present, there is a possibility of corrosion. Okay, so most of the metal should be making alloy. For making alloy, reduce the rate of corrosion with suitable, alloying with suitable elements. Okay, let us see the next one. So a few examples I have explained. So the first one, the maximum corrosion resistance alloy should be completely homogeneous. That is very, very important. So whatever the alloy you are manufacturing, the alloy should be completely homogeneous. Then only it is effective. Otherwise it will not effective. So the best example, chromium is the best suitable alloying material for iron or stainless steel. Okay, so 13% of chromium are used in cutlery and surgical instruments. So 13% of chromium as an alloying material in coordination with iron. So the corrosion will be, rate of corrosion will be very, very less and reduced a lot. And another case, 13 to 25% of chromium called ferrite stainless steel are used in turbine brackets, heat resisting parts. So corrosion will be reduced a lot. Such kind of alloying format. Another method, that is annealing method. Suppose you are having a metal. So if you want to protect the metal, then you can go for heat treatment based on the metal conditions. Okay, so heat treatment is, annealing is nothing but your the metal is exposed in heat treatment. So what kind of things happen if you are heating? It reduces the internal stress and the rate of corrosion. Internal stress will be reduced, so the corrosion will be reduced. And then before your applications, you have to do it. Then by eliminating galvanic corrosion, so two metals are to be in contact, they should be selected based on the electrochemical series. So the electrochemical series means arrangement of electrode potential. There is an order in which the electrode potential, based on the electrode potential, the metals are arranged in an order. Okay, so if it is very close to each other, the rate of corrosion will be less. Okay, now let us move to the design aspects. Design aspect means as long as the length and size of the objects, the joint or bolt should be lesser in number. Okay, then there is a possibility of less corrosion. If the joint, because we know that pitting corrosion and crevice corrosion, everything is based on the design aspects. Because a lot of bolts are there, means wherever the nut and bolts, there is a possibility of corrosion. Okay, even though if you are protecting with the coating and all other things, it's very difficult to maintain the uniform, unless otherwise if you are using spray coating. Okay, avoid the content of dissimilar metal in presence of a corroding solution. So corrosion is localized on the more active metal while less active is protected. Okay, so if two dissimilar metals are in contact, then the material should have a large area as possible. Okay, this is all the thing I have already explained. Okay, so design aspect, the most importantly, the anodic metal should not be painted or coated. Very, very important. So the cathodic metal only should be painted or coated properly, because any break in the coating would lead to rapid localized corrosion. So anodic material should not be painted or coated. Okay, so another one, we have to maintain the homogeneity, that is already explained. Okay, another important thing, the metal contact should be avoided. Metal contact should be avoided means, then how can we suppose if there is a condition to join a metal to metal, so in that case you can use an insulator in between the metal. Okay, suppose in your design, if you want to connect these two, then avoid this direct metal contact. So you have to in between you have to connect with the insulator. Okay, another few things you should know, the design aspects. So if you look at the picture, and I think in the next picture, yeah, you will get. So sharp corners should be avoided. Sharp corners should be avoided, and the joint and bend. So even you can see in many of the objects, even in your house or in your office, if you look at the object where the corrosion occurs, if you look at carefully, only the joint and the bolt and the sharp object. Okay, so those kind of parts only the rate of corrosion will occur normally. Okay, that is very important. And equipment should be supported on legs to allow free circulation of air. Another important thing, equipment should be supported on legs to allow free circulation of air and prevent the formation of stagnant pool or damp. That are also the reason for corrosion. Okay, the third one, first one is material selection, the purity of the metal, and then the design aspect. Second one is design aspect, and the third one is cathodic protection. This is another important one. The principle behind this cathodic protection is to force the metal to be protected to behave like a cathode. Thereby, corrosion does not occur. Because we know that at the anodic region only oxidation takes place, electron loses, so corrosion occurs. So what we have to do, we have to force the metal to be act as a cathode. That kind of principle is known as cathodic protection. So this can be achieved by two different ways. One is sacrificial anodic protection method. Another one is impressed current method. Let us see one by one. Okay, sacrificial anodic protection method means, so the metal which you want to be protected is connected by a wire to a more anode metal. Say simple, you just imagine we are having a lengthy object, lengthy rod. It should act as a cathode, means it should be connected through a wire, the anode material. So most of the anode material is zinc, magnesium and aluminium. Okay, zinc, magnesium and aluminium, any one should be connected via a wire. So what happens? So the cathode is connected with the anode via a wire. So we know that where the oxidation takes place at the anodic region. So the anode region loses its electron and corrosion occurs. So the cathode is protected. So the anode itself corrode. That's why this kind of anode is said to be sacrificial anode. So the very simple, the anode is very cheap. So once the anodic material is corroded, you just remove it and you can connect with a fresh anodic material. Very simple. So your material, your object is always protected. Corrosion does not acquire. So the same thing, the corroded sacrificial anode black is replaced by a fresh one when consumed completely. So the best example, zinc, magnesium and aluminium. Look at this picture, you can clearly understand the concept. So one big pipeline, it is in the underground. So buried under the ground. Okay, so the lengthy pipeline is there. So if you want to protect this pipeline, it should be connected with the anode via a wire. Look at this image, look at this. See, this is the cathode material. It is buried under the ground. Okay, so it should be connected via a wire with magnesium or zinc or aluminium. Okay, so this acts as an anode. So once it is corroded completely, you just remove it with a fresh one. That is possible. Very simple and economical one. Another one, if you look at here, the same thing, industrial. This is in the boiler case. This is in case of boiler. If you are looking at a boiler, the corrosion may be avoided by connecting it with the magnesium or zinc. Okay, so this technique is already is also applied in ship. If you look at the ship, so if you look at this, here on the more oxygenated part, less oxygenated part. Here it is more oxygenated part. Okay, so the differential aeration corrosion will acquire. So you can see in the seashore area, you can see the corrosion mostly occurs at this region. Okay, so how can we control? So here it should be connected with the magnesium or zinc or magnesium or aluminium via a wire. So the corrosion occurs here only. So you can frequently remove this one. So this kind of technique are said to be sacrificial anodic protection method. Okay, right. Now let us see the next two. Same thing. What are the advantages and disadvantages? I have already explained. Once again, go through low maintenance and installation cost, because very simple. Your object is still as it is, just connecting via a wire with the anode. It does not require external power supply. There is no need to supply any power. Cathodic, because in the next method we are using electric current for the second methods, and the cathodic interferences are very minimum. Disadvantages: more than one anodic strip is required sometimes. It does not work well under severe corrosive environments. Okay, these are all the disadvantages. Okay, the second method, impressed current cathodic protection. Here electrical supply is required, power supply is required. So that is the only thing difference between the previous and the current one. In this method, an impressed current is applied in opposite direction of the corrosion current to nullify it. Therefore, the corroding metal is converted from anode to cathode. So this can be done by connecting a negative terminal of the battery, that is electron supply, to the metallic structure to be protected. And the positive terminal is connected to an inert anode like graphite and platinized titanium. So the anode is buried in a backfill containing mixture of coke, breeze, sodium sulfate. The backfill provide good electrical contact to anode. This kind of protection technique is particularly used for large structure for long-term operation. Long-term operation. Okay, look at this picture. So this is your objects buried under the ground. Okay, this should be act as a cathode. Okay, so the negative terminal of the battery, this is the battery, you have to power supply. Negative terminal of the power supply to the cathode, and the positive terminal is connected to the anode. So by the way of supplying electron, the object is protected. Okay, so the difference between the above two method is very simple, as I said already. Here sacrificial anodic method, no external power supply is required, but here continuous power supply is required. In this method, periodical replacement of sacrificial anode, because once the anode is corroded, you have to replace it. Here anodes are stable and do not disintegrate. Investment is low because nothing is, only you have to connect via wire. But here investment is more because you are going supplying external electrical power. Soil and microbiological corrosion effects are not taken into account, but here it is taken into the account. This method is most economical when short-term protection is required. This is well suitable for large structure and long-term operation. Okay, now let us move to the second category of protection, that is modifying the environment. So first category is over. Now let us move to the second category. How can we modify the environmental conditions? So the first one is de-aeration. In oxygen concentration type of corrosion, based on the concentration of oxygen, the rate of corrosion influences. It is increases. If the increased amount of oxygen is harmful and increases the rate of corrosion. Okay, so how can we reduce the oxygen concentration? So this effect of dissolved oxygen can be removed by the use of chemical substances like sodium sulfide and hydrogen. Among the two, hydrogen is the best way to remove the oxygen concentration. Very simple equation, just look at. If you are using sodium sulfide, it reacts with oxygen to form sodium sulfate. Again, it is a salt. Whereas in case of hydrogen hydrate, it reacts with the oxygen to form nitrogen and water. Both are harmless. So that this is the best way of using deactivation. Then next method, dehumidification. In this method, moisture from the air is removed by lowering the relative humidity of the surrounding air. So this can be effectively done by adding alumina or silica gel, which absorb moisture preferentially on its surface. Okay, so this is the simple way, alumina or silica gel, which acts as a good adsorbent. And the third one, reducing the acidity, because we all know that corrosion, the rate of corrosion will be increased in the medium of acidic environment. Okay, so how it can be avoided? Very simple. You can convert the medium into the neutral by the way of adding ammonia or sodium hydroxide or lime. And use of corrosion inhibitor. So this is one of the important method to control the corrosion. Corrosion inhibitor to be added. Okay, so what are the inhibitor? Anodic, let us see anodic inhibitor. So anodic inhibitors are nothing but oxygen and oxidizing agents. They get absorbed on the metal surfaces, forming a protective film or barrier, thereby reducing corrosion. So the best example, chromate, phosphate, tungstate. These are all the best example for anodic inhibitors. Okay, cathodic inhibitor in the acidic medium, The corrosion can be either controlled by slowing down the hydrated H plus ions to the cathode, or increasing the over voltage by hydrogen evaluation. So how it is happened? Diffusion of H plus ion is decreased by organic inhibitors like amine, heterocyclic compounds containing nitrogen, substituted ureas and thioureas. These are all the chemicals capable of being adsorbed on the metal surface. So which can be effectively controlled by diffusion of H plus ions. Increasing the over voltage by hydrogen. So the best example, antimony and arsenic oxides are used as an inhibitor for effectively reduce the corrosion. Then property of the metal. Okay, so converting the active surface of a metal, passive film. This one I have already explained in the with some example in my previous lecture. What I have just imagine, you have two metal you have to take. The two metal like silver and tin, both are exposed in the chlorine gas environments. Okay, so silver react with chlorine to form a silver chloride, tin react with chlorine to form a tin tetrachloride. So both are forming their respective chlorides, but silver is protected and tin is corroded. What is the reason behind that? Very simple. Silver forms silver chloride. Silver chloride is non-porous in the structure. Structure of silver chloride is non-porous, so the metal is protected. No porosity. So no porosity means further attack is not possible. Further attack of chlorine is not possible because silver chloride is stable. Whereas tin tetrachloride is not stable. It is porous in nature. That's why further attack is possible. Tin tetrachloride. So tin is corrode. This is the example I had explained in the previous. So now here the same aluminium and the tin. If you look at, both are exposed in not chlorine medium. Both are exposed in the atmospheric medium. Okay, exposed in the air. So rapidly it is converted into their oxide, aluminium oxide, tin oxide. So these oxides are stable, non-porous nature. That's why it is passivated. The metal is passivated. That means metal is protected. Okay, so similarly, iron is passivated by alloying it with any of the metals like chromium, nickel, molybdenum, titanium, niobium. These are all the alloying material with aluminium, iron. So iron is passivated by this kind of metal. Look at the coating, protective coating. So in olden days, people are using like for protecting the metal in our home or any other objects by simple way of painting. Simply, you can make a painting. Now, most of the places people are using spray coating. Spray coating, actually, even though the metal object will be in a good condition, the protection is over, but it is very difficult. We have to maintain proper proper safety measures. Otherwise it is very difficult because it is fly away. So while spray coating, many preventive measures, precautions to be taken. That's why it is not advisable for the home. But if we are using such kind of things, you can implement such kind of spray coating. Otherwise, it is not at all advisable in home because it is harmful to the environment. But painting is somehow is good for making paint. It is not much hazardous because it will not fly away. So, but effective coating is spray coating. Painting means some places dark, some places if it is not uniform, again there is a possibility of breaking such kind of structure. So such kind of problem will be faced on painting. Okay, look at the not only spray coating, many kind of methods are there. like organic coating, organic coating, inorganic coating, metallic coating, ceramic coating, hybrid coating. So various types of coating is available. So how it happens? So this is the thing is explained in book chapter AC Symposia. So just look at the image, how the coating is, how the corrosion occurs. So based on the environmental or other conditions, the metal is completely corroded. So you can see a lot of corrosive products are there here. Okay, so after a proper coating, the same object, look at after coating, so it's look very nice, and the life will be increased. Lifetime of this object is increased. Hope I think all of you understand how can we control the corrosion. Okay, so in my next lecture I will explain about the plating, electroplating and electroless plating. So almost I have covered all the factor except electroplating and electroless plating in the corrosion. So that I will explain in my next video. Thank you so much.